Stand up from your chair for a second, or just picture doing it. In that movement, your body sent a single message that accomplished two completely different things at once. And when I understood how that works, it changed how I think about the phrase low energy. Let me build this up properly. Here's the assumption most of us carry around. Your muscles need energy to move. So the sequence must be something like this. You decide to move, your muscles start working, they burn through their available energy, your body detects that things are running low, and then it ramps up production to catch up. That's a feedback system. Demand happens, the shortage gets noticed, supply responds. It's how a thermostat works. The room gets cold, the sensor notices, the heat comes on. Your muscles don't work that way, or at least not only that way. Let's start with how a muscle actually contracts. Inside your muscle fibers, there's a structure called the sarcoplasmic reticulum. Think of it as a storage network that runs all through the fiber, and what it stores is calcium. When a nerve signal arrives, it depolarizes a structure called the T-tubule, which runs into the fiber. That triggers a channel called ryanodine receptor 1 to open, and calcium pours out of storage into the surrounding space. That calcium is what makes the contraction happen. It binds to the machinery that lets the filaments pull past each other. No calcium, no movement. It's the trigger, and it's the whole reason the muscle does anything at all. Now here's the part that I want you to sit with. Your mitochondria and muscle aren't scattered around randomly. They occupy something like 10 to 15% of the volume of the fiber, and they're positioned very specifically. They sit within a region called the I band, wrapped around that same sarcoplasmic reticulum network. They're parked right at the calcium release sites. So when that calcium floods out to trigger contraction, the mitochondria are close enough to catch it immediately. There are dedicated structures for this, a chain of proteins that bridge the gap between the storage network and the mitochondrion and hand calcium across. Researchers describe this arrangement as quasi-synaptic, meaning the transfer is so fast, so local, and so direct that it resembles a synapse between two neurons. The calcium moves across a tiny defined gap rather than diffusing through the cell. And when calcium arrives inside the mitochondrion, it does something specific. It activates enzymes. Several of the key enzymes in the citric acid cycle are calcium-sensitive. Pyruvate dehydrogenase, isocitrate dehydrogenase, oxyglutarate dehydrogenase. Calcium switches them on. The citric acid cycle feeds electrons into the electron transport chain. The chain produces ATP. So calcium arriving in the mitochondrion means the whole production line speeds up. Now put the two halves together. The same calcium release does both jobs. It triggers the contraction, and it accelerates the energy production that pays for the contraction, simultaneously, from one signal. That's not a feedback system. That's what engineers call feed-forward. Your body isn't waiting to detect a shortage. It's ordering the work and the fuel in the same message at the same moment because the message is the same molecule. I find that genuinely beautiful. The instruction and the funding arrive together. All right, what do you do with this? The practical implication is almost embarrassingly simple, and it's the one thing I want you to take away. This entire pathway is downstream of one event: contraction. No nerve signal means no calcium release. No calcium release means no message to the mitochondria. The enzymes don't get switched on. The production line doesn't speed up. The whole elegant system sits idle. You cannot activate this by resting. You cannot supplement your way into it. The signal is generated by muscle firing, and there's no other route in. So the free lever today is movement. And I want to be clear about what I mean because this isn't a training program. Walking counts. Carrying your shopping counts. Stairs count. Standing up from a chair repeatedly counts. Anything that makes muscle contract sends this signal. It's Saturday. You've probably got more freedom today than you do most days. Use some of it moving. Now let me be honest about the limits of what I've told you because there are two real ones. First, there's research showing that in aged animals, the proteins that ferry calcium from storage into mitochondria are present at reduced levels. The bridging structures get downregulated, and that calcium signaling becomes less efficient with age. That's an interesting and slightly worrying finding. But that's mouse work. It has not been demonstrated in humans the same way. So I treat it as a plausible direction rather than an established fact about your body. I'd rather flag that than let you assume it's settled. Second, and this one's more important, calcium is not the only thing controlling how hard your mitochondria run. There's a long-standing debate in this field. Studies in human arm muscle using magnetic resonance techniques concluded that the principal control of oxidative metabolism in skeletal muscle comes from a different molecule entirely, essentially the breakdown products of used-up ATP signaling that more is needed. That's a feedback mechanism, and the evidence for it in humans is strong. So the honest picture is that both are operating. There's a feed-forward calcium signal that anticipates demand, and a feedback signal that responds to actual depletion. Researchers combine them into models with both components. Anyone telling you calcium is the master switch for muscle energy is overselling one part of a more complicated system. I'm telling you about the calcium half because it's the counterintuitive half, and because the practical takeaway is identical either way. Both systems are activated by the same thing: muscle contracting. So, where does my own recommendation sit? Everything I've described is about signaling. Calcium is a message telling the machinery to run harder, but the message has to arrive at machinery that works. CoQ10 is a physical component of that machinery. It's one of the carriers in the electron transport chain, moving electrons between complexes so ATP can be produced. Levels tend to decline as we get older. I want to be careful about how I put those two together. I am not telling you a supplement improves calcium signaling. Nobody's shown that, and it's not what these studies looked at. What I'm saying is that we've spent this video on the signal, and there's a separate question about the equipment the signal is shouting at. So the order stands: move today. That's free, it's the only way to send this signal at all, and it's the single most supported thing in this entire video. And if you want to support the machinery the signal arrives at, the link in the description below is an affiliate link to Mitochondrial, which is PQQ and CoQ10, and it comes with a 90-day money-back guarantee. If you like getting the caveats along with the science, subscribe. That's the whole point of this channel. This video is educational only, and it's not medical advice. Talk to your doctor before starting a new activity, especially if you have a heart condition, a muscle condition, or you've been inactive for a long time.